So they're looking at different spots. So you end up using a different max P table. And the main difference that is sort of the real underlying problem is that for in the good file there's this FFFF there in this table, but it corresponds to max size of instructions. Because everything is shifted now. In the bad file, instead of that, the FFFF becomes max component points, and it turns out that's bad. So what Dion does next is he creates a new PDF that's not compressed, so it has an uncompressed font, and then he manually makes max component points FFFF. And what he finds is then Adobe Reader still crashes in the exact same way, but now we have a very small PDF, it's uncompressed, and we know exactly what's wrong. So it's the same crash, but now it's easier to analyze. He's starting to kick my ass, so we need to start improving, or else you'll be like, well, I'm just going to hire Dion. I'm not going to even use BitBlaze. So now I go back to BitBlaze. So I have the simpler PDF now. So now I take the simpler PDF that's uncompressed, and I now taint the FFFF, and I see what happens. So instead of tainting the CF from the compressed font, I'm rerunning everything with the FFFF tainted to see what happens. Okay. So I do the same exact thing again. I say, okay, tell me what instructions were dealt with tainted data, and they were inside of the cool type DLL. That's what that grub is for. And right off the bat, the very first lines, it starts to tell me how this FFFF gets used. So first it reads the 6th byte of offset, reads that into DH, and then the 7th byte. So it's reading it's reading both of those FFs, so they're both important. And then what's it do? So now they're in DX. And then down there, it adds 8 to it. Okay, that's fine. So it's FFFF plus 8. So it's 1007. And it pushes that to some function. But then what does the function do? Oh no, it thinks that it's a word, and it copies it into ESI. And so instead of being 1007, it's now just 7. That's an integer overflow. So, and I was able to find that real quick. So 2 to 2, it's a tie. Right? That's the nice way to always end a talk. So then what's the end of the story? And this is all outlined in the actual white paper, but I don't have time here. So this FFFF we saw had 8 added to it. It overflowed. And then it uses this for an allocation size. So it multiplies by 4 to get the size, because it's like D words. So the size in the bad file is 1C. It's way too small. 11 buffers are allocated to this size, and then routines start operating on these buffers. They think the buffers are really big, like 40,000 bytes big, but really they're like 30 bytes big or something. I don't know. And so they all smash on each other, and then you get crashes and stuff. So that's the bug, and we were able, that's the competition. But then it was like, I said it's a nice way to end talks, but I'm not really that kind of person. So I want to have a winner, right? I'm an American. We can't have ties. So the next thing was Dion. He actually goes, and so BitBlaze can't do this. So he actually writes, he does the heap spray. He gets everything running, and so you can't argue with that. Dion is the winner this time, but still, BitBlaze did good. Okay, so got a couple minutes to finish up here. Let's talk about a little bit. So BitBlaze did pretty awesome on these things. It's still not going to replace Dion at this point, but hopefully it sped up the process. And there's some things that BitBlaze did that if we wouldn't, we were still sort of working together, that if I wouldn't have shown him, oh, this is where this came from or that where it came from, it would have taken him a lot longer. Okay, so the trade-offs. BitBlaze, I already said this, it's not fast. So it's something you have to basically run overnight to get the traces. There's also some things it can't do because it runs out of memory. So if you want to do full taint runs for those crash reports with taint, sometimes you'll run into problems. The traces are sometimes many, many gigabytes, so you got to have a big hard drive ready to go. And again, the bottom line I think is that it might not be faster. Like if you said, Charlie Miller, you need to find exploit for this bug in the next 2 hours. BitBlaze probably wouldn't be the tool for me. Because in clock time it's not really faster. But if it's okay, you have a week to do it and you have 10 of them to do, well then it's probably a good choice because it's going to be able to, I can run it overnight and then it'll help me while I'm actually thinking about it go faster. Okay, so conclusions. BitBlaze is a general tool that can do lots of things. In particular, it can do this crash analysis. Crash analysis is tough, and even with taint information, there's a lot of times you don't know what to make of crashes, but it is something that will hopefully speed up your reverse engineering. The white paper, like I said, it's like 70 pages. It's full of gory detail. Check it out. Code's available too. This is the BitBlaze team. So they were great. They did a great job. Their tool works. And so here's links to the code where you can get BitBlaze and play with it yourself. Also links to the slides from today and the white paper. So please check it out. And that's it. So I don't know if we have like 3 minutes for questions. If anyone has any questions, we'd be happy to take them. Yeah, back here. Yep.
So it looks like I can fully automate the tracing and the tainting, but not the.
So this is a guy who had his picture in the slide, so he thinks he can ask a question. It's Ben, right? I can't really see, but I think so. I recognize his accent. So he's the guy who finds like 200,000 crashes in a work. Okay. What's your question?
So it looks like I can automate the trace dump and the tainting because I can just do that and automatically taint it, but not the subsequent analysis. Is that right?
So he was asking what can be automated and what can't. So you can certainly automate the trace taking. You can automate the crash dumps that have taint information, and then you could write little heuristics on top of that. You can automate like some val set stuff. So like if you notice things are tainted at the crash site, you can ask how much control you have over those things. But like knowing you could automate a slice, but it wouldn't really do you any good probably because it sort of takes a human to interpret that. So yeah, there's a lot of things you can do, but then the sort of figuring out the bug part, still it's going to take a human to look at that. Yeah, back in there.
Maybe I'm.
How come? And how hard to bring that on stream?
All right. So the question is, how hard is it to support Windows 7? Noah.
Right. So for the Windows platforms, of course, we don't have the source code, and for getting this operating system level semantic information, we need to sort of get deep into the internals of the system. So it involves sort of manually reverse engineering the kernel, and we just don't have the bandwidth right now. But that's sort of the next step. So
it's not a QEMU-based limitation from the old code base you're using.
correct. So it's just so QEMU might support Windows 7, but we need additional information not provided by QEMU. That's where the TMU extension comes in. And so it's not that it's not possible to do, it's just that we haven't done that yet, and we have no need because all the samples can run fine in 2000 and XP. Right? But it's on our to-do list.
Thank you.
Is BitBlaze free? I didn't see it. I came in late, so is it free and open, or is this an enterprise product?
BitBlaze is free, first of all. The core components of BitBlaze are open source, and you can find those at our website. We've also released binary-only versions of some of the tools that we've shown in this presentation, and you can get the distribution from that at this link.
So it's all free, some open source, some still closed source, is that right?
Correct. Yeah. Most of it is open source. There's just a few tools that we haven't yet released publicly.
Any other questions? Oh, yeah.
The trace file you had for every single process, right? The whole OS and subsets.
The trace files we were looking at were for just a single process, but the trace collection utilities can output traces for every process.
Okay, so thanks.
All right, so you get a trace for the process that crashed or whatever, and then you can actually also just find out the instructions from that trace. Even finer are only the ones that deal with tainted data. You can ask it that too. But yeah, you don't have to worry about all the processes. That's one of the things that it does for you. Other questions? I think we're out of time anyway, so thanks everybody.